Alright, ladies and gentlemen, this is going to be some notes about the nature of sound. We'll break it into three parts, so there will be three separate videos, and they correspond with the days in which we covered some of the material in class. So you can check out each video independently, but you do need to make sure you check out all three when it's all said and done. So first, just basic fact stuff about sound. We've talked a whole bunch about waves in general, but now we'll talk about sound specifically. So we start off with what is sound, and it's a vibration. It's this complete back and forth motion. If you've ever seen a speaker work, it fluctuates back and forth, and that pushes on the air particles so they squeeze together, and they move forward and bump into some other air particles, and then when the second set of air particles are going to move, they start to stretch apart from the previous particles. So sound is produced by vibrations in an object. Whenever an object vibrates, it causes particles in the air to move, or whatever the medium is to move. And that ultimately creates sound. Now, when someone speaks, it's like vocal cords vibrate, causes air particles to vibrate, which cause more air particles to vibrate, which cause more air particles to vibrate, ultimately striking your ear, and that allows us to perceive that wave as sound. Now, sounds are mechanical waves, so they do require a medium. Now, that medium can be a solid, it can be a liquid, it can be a gas. We know that all of them are viable options for a medium, but sound does in fact require a medium, therefore it is a mechanical wave. Now, if we were to look at this chart here, we can see like the different speed of sound waves through a variety of different media at 20 degrees Celsius. So we can see that aluminum allows sound to travel the fastest of these materials, much faster through aluminum than a sound would be traveling through air. In fact, almost 20 times faster sound will travel through aluminum than it does through air, with various speeds in between. But if you look, you have like solid. They have the fastest speed, and then a liquid is kind of lower than that, and a gas, dry air, this has the lowest speed by far of the different media that are presented there. So the speed of sound is determined by the medium that it's traveling through. We've talked about this with waves in general, mechanical waves in general, how the medium itself will affect the rate at which sound travels. Now, we can look at these different substances, and we see that the solid, particularly aluminum, has sound travel fastest, where the gas has it travel slowest. But the other important factor is this 20 degrees Celsius factor, and that is an indicator that temperature becomes relevant, and it really does. Now, this seems a little counterintuitive, but while solids have the fastest rate of speed, the speed at which a sound will travel increases as the temperature of that solid increases. This means that if we were to take like a block of aluminum that has a high temperature, sound would travel faster through it than a solid block of aluminum at a cold temperature. And the reasoning for this, if you remember back to when we talked about temperature early on in the year, temperature is an indicator of the average amount of movement of the particles that make up the object. So we want the particles to be really packed closely together, but we also want them to be moving as much as possible. So if we're going to look again and talk about aluminum as an example, sound will travel fastest through aluminum as a solid, particularly as a solid that is hot. But if you increase the temperature too much and that aluminum melts, all of a sudden the rate at which the sound travels through aluminum has decreased to because it's now a liquid and the particles are much more spread apart. So even though it's hotter, it's now shifted its state and to a liquid, and it's going to slow down the speed of sound. So most important, what state of matter we have, solid being the preferable state of matter for a sound wave to achieve its maximum speed. But then as we're in that state, we want the temperature to be as high as possible within that state of matter. So that's it. I mean, that's the basics for part one of our video here. So come back, check out the other videos as well to make sure you get all three of them covered.